and welcome to your next video on water. Now, as we continue talking about the chemistry of life, we need to talk about an essential part of the chemistry of life, and that is water. Water is essential for many parts of the chemistry of life, so we're going to go ahead and see what all it does for us. So how much water do you drink? As we go through this lesson, think about all the water you drink, and think about the plain water you drink. Water is essential for many, many processes. So start thinking about drinking a bottle of water instead of a soda. So our facts about water. 65% of the human body is water. 75% of your brain, the human brain, is water. And 75% of a living tree is water. You can only survive a month without food, but only 5 to 7 days without water. So what's the big deal with water? Well, water supports our life, and there are 4 main reasons water supports life, but all are due to a special bond. This is a type of bond we have not yet talked about. This is called the hydrogen bond, so make sure you know this. It's a bond between a hydrogen and any other atom that likes electrons more than hydrogen, which we call electronegative. Oxygen likes electrons more, so it draws electrons toward themselves. So oxygen is very electronegative in our water molecule. Remember, water molecules are made of 2 hydrogens and 1 oxygen atom. So hydrogen bonds are individually weak, but collectively strong. So if you only have 1 hydrogen bond, it's not very good. But if you have lots and lots of them, like in the ocean, we have a lot of hydrogen bonds between all those molecules of water. We have a very strong bond. So we said there were 4 main reasons. We're going to go through these main reasons. The first one, how do trees get water from their roots to their leaves? Well, that's not really the reason. The reason I'm going to talk about what they use to get water from their roots to their leaves. So the first is cohesion. Water bonds to itself. So that water is kind of towing itself up from the root to the leaf. And what that is called is capillary action. If you've ever put a paper towel in a puddle of water and you've seen that water go all the way up to the top of the paper towel, that is capillary action. This cohesion, this bond of water to itself, is also called surface tension. And that's what causes leaves to float on water. That's what allows some bugs to walk on water. It creates a tension through those hydrogen bonds. So that is cohesion, water bonding to itself. We also have adhesion. So the water doesn't just bond to itself, but it also bonds to the tree, the trunk. It has to get up to the top, and it needs help besides itself. So it's going to bond to the sides of the trunk to get up to the top. So both the adhesion and the cohesion are going to be forces that help move up the tree. These are going to be used in other processes, but one of them that we use is getting water from the root of a tree to its leaves. The next one, how does the ocean survive in the winter? Well, it might get really cold, and we need to know what happens. Well, the big thing is ice floats. Ice has a lower density than water, and so in its solid form, ice, it floats on top of the water, and it creates an insulator. So it insulates everything below it, and that life can continue as it was before. So when water freezes, those hydrogen bonds, we're going back to those hydrogen bonds. Remember, I said they were very, very important. We're still talking about these hydrogen bonds. They form and create a 3D crystal that is less dense than the water. So if you see all of these red molecules here with the yellow, those are all water molecules, and they've created a 3D crystal structure, but it's become less dense. So that less dense is what creates the ice, and then the ice is able to float, creating that insulating layer. So why do oceans stay the same temperature all year round? Well, not only does the ice float, like we just talked about, but water moderates the temperature. Water has what is called a very high specific heat. Have you ever been to the Atlantic Ocean in July and it's freezing still? This is due to specific properties of water or that high specific heat. It takes a lot of energy to bring that water up in temperature. And this again is due to the hydrogen bonds, and we're going to talk about that here in a second. It's also because the Atlantic is so large and in cooler places, but having a vastly large body of water is going to take even more energy. So this is because it has a high specific heat, and it takes a lot of energy to change the water's temperatures, even just a few degrees. So why? It's hard to break all those hydrogen bonds. The hydrogen bonds are the key to almost every property of water. So when we ask about something, think about these hydrogen bonds. The hydrogen bonds are the key to the properties of water. Why is our body 65% of water? Well, that water is key to all the processes in our body, but water is the universal solvent. My blood is mostly water, and it carries my nutrients. It transports them. So that universal solvent is transporting them all throughout my body. And water is also polar, which oxygen has a negative charge and hydrogen has a partial positive charge. So it makes it easier for it to dissolve different compounds and ions. I'm going to show that to you here in just a second. So this is how we actually dissolve different compounds in water. So you know how you dissolve sugar or salt or anything in water. What you start out with is you start with a compound, let's say sodium chloride, the NaCl. You're going to see this crystalline structure, what you're actually putting into the water. And you have all these little water molecules all around, and you have the crystals still. And the crystals are going to start to break apart due to the partial positive and negative of the water molecule. And then eventually you're going to have these partial positives and negatives start to bond to each other. So if you have a negative atom or ion, you're going to actually form a hydrogen bond between the hydrogen if it's a negative ion, or a hydrogen bond between the oxygen and the positive ion. So when you dissolve something, you are creating a hydrogen bond between that ion and the water molecule. If you are not dissolving it, there is no bond being formed. So anytime you dissolve something, you are disassociating the ions of the crystal, and then you are creating bonds through hydrogen bonds in the water. Lastly, the last thing I want to talk about here is the pH scale. You've probably heard of the pH scale, seen it all over. There's not a lot I need you to know here. pH stands for percent hydrogen, and what we are actually measuring is the percent of hydrogen in the compound. A perfectly neutral compound like distilled water is going to be 7. Now, a basic compound is going to accept hydrogen ions, or it will donate hydroxide ions, and that's going to raise the pH. Anything above a 7 will be a basic pH. So ammonia, milk of magnesia. One of the very common traits of these is if you can feel it with your hands, and if it is safe to feel with your hands, it will often be a very slippery feeling. So soap is a basic compound. Acids, on the other hand, tend to feel a little gritty, and they're going to be below 7. Now 6.8 technically is a acid. Anything below 7 is an acid, and they're going to donate those hydrogen ions, which is going to lower our pH. So from 0 to 6.999, you have an acid. From 7.1 to 14, we have a base. So we're going to accept those hydrogen ions for the bases, we're going to donate them for the acids. So that's all I need you to know for the percent hydrogen pH scale. Okay, so I'm just going to review a little bit here for you. So remember, we have 4 main reasons that water supports life. They are mainly due to our hydrogen bonds. We have cohesion and adhesion. Cohesion is where water bonds to itself. Adhesion is where water bonds to something else. Remember that ice floats. This is due to the density and the 3D crystalline structure. We also have that water moderates temperature due to its specific heat. It takes a lot of energy to raise the temperature of water. It's due to breaking of those hydrogen bonds. And lastly, water is a universal solvent because it is polar. So we're going to be creating those hydrogen bonds to dissolve things. Okay, I hope you got great notes. You drew great figures, and we'll be talking about this in class later.